Hey everybody, it is 9 a.m. on March 1st and it's HTM Hackers Hangout. Thanks for joining us. Got a couple of people live. I hope you guys don't mind. I want to go through a few things first, and then we're going to have this long discussion about 2G object recognition, this project that I've started on the HTM forum. So I'm going to save that till the end because I'm going to draw on a whiteboard and sort of describe some technical details about the spec that I'm imagining and take some Q&A if anybody has any. But for right now, I want to get through some of the rigmarole that I got to get through on these things. So in the forum page for this, I've listed these topics out, and I am going. I see. I don't even have the controls right. Anyway, oh, there we go. Okay. Okay. First thing, Python 3. I'm going to mute everybody also for now. So Python 2 is dead. Like there's no Python 2 is like end of life is like January. After that, there's no guarantee pip install newpick will ever work on any environment created after that point in time. So that's a big problem. We want, like, pip install newpick was a big deal. It got a lot of people available. It made it available to a lot of people. So we have some big decisions to make the Numenta about how we're going to handle this. You know, we have options. One, do nothing. That's an option. Two is update newpick to use Python 3, which would be newpick 2, which would be a bunch of cleanup, and we would take. Then we have a bunch more decisions to make. Right. We're going to make all these decisions in March. I've got a meeting scheduled when everybody's in the office at the same time, and we're going to get it figured out before the deadline comes. So by January, we're either going to have a newpick 2 that's Python 3 compliant so that people can pip install newpick. There's not going to be any enhancements. It's really just going to be cleanup. The API is going to be as similar as possible. We might remove the OPF. That's a part of it, just for cleaning up. I don't know. There's a lot of stuff on the table. Anyway, it's a big deal, and it's a lot of work, and there's a lot of decisions to be made, and we're not taking it lightly. I just want to let you guys know. And I am paying attention to what's going on in the fork. The community fork, which is the next thing I wanted to talk about. And David, you're online. It'd be great if you could give a quick update because I see a lot of activity.
Well, let's see.
Python 3 in particular is important.
Can you hear me, or am I?
Yeah, I can hear you great. Okay.
Well, we've got some major changes in there. We're trying to get it organized so that the idea was maybe we'll be the next newpick 2, but we're kind of going on our own direction, not having any direction from anybody else. So that's why the forum was asked what they want. So if you've got inputs that you'd like to give us, that's fine. We're open to a lot of things. If you'd like to participate and help out in this effort, we got lots of room, lots of work to do. I don't know, what else would you like to know?
I just nothing in particular, but anything you want to know, that's perfect. And like I said, everything is on the table right now. We haven't made any decisions about what we're going to do, but we know that newpick, as it is right now, is not going to work. Is going to be basically a legacy project after January unless we do something. And I don't think we want to do that. So, and definitely if I in particular, because I'm going to be doing a lot of this work. I mean, it's going to be Lewis and myself that are going to be doing whatever work for the most part, and Subutai if he has time. That's going to be doing this transition, this Python 3 migration if we end up doing it. I'm going to look through the community fork pretty thoroughly. To see what you guys have done. I know that you pulled Swig out, I think, and PyBind is in place now. That's definitely something I would want to do. Getting rid of serialization is definitely something I would do. So there's a lot of alignments there. We're going to do what makes sense, and we'll be in communication. You know, I will definitely as a community manager. So I don't think any of your work has been in vain, even if we do end up putting out a newpick 2 that's just Python 3 compliant, just to put that stake in the ground. You know, and using the lessons that you guys have learned to do that, even if it's not the same code base, and you guys continue going off in your direction, because I do not know what's going to happen with newpick in the future. We one of the options we always have is to start fresh. You know, if the theory has progressed to a point where it doesn't make sense to pull this stuff along with us, it's always another option, and everything's on the table. So I just want to let you guys all know that things are probably going to change over the next year in the landscape, and we will take the lessons that you guys have learned and the work that you guys have done into account. Okay, so that's all I have on that, unless anyone has an opinion they want to, at any point you guys want to talk, unmute yourselves and pipe in. So the next thing is on applying HTM to current machine learning environments. You know, I know that we have a thread in HTM forum about this, and I've been like leaking some of the tactics, but honestly, we have this paper, it's almost done. I'd really love to share everything in it, but we anonymously submitted it to a conference, and we can't really share it until the conference tells us whether it got in or not. So I don't want to say any details about it. And at this point, the more I leak, the more confusing it is, and the more confused I make everybody. So just hold tight. The paper I think is going to be good. I've reviewed it several times, and I'm working on a video that'll explain it. Like, here's, you know, this type of deep learning setup, and here's how you can add like HTM stuff to it. You know what I mean? So just keep that. I'll get that done. It's like the main thing that I'm working on right now, but we want to make sure that we use all the right terms and everything, and we're communicating properly in, you know, what I'm creating versus what Subutai and Lewis are writing. Okay, next topic was swarming. There's a Sam Heiserman, who's usually at these, was doing something with swarming. He's asked me questions. Can I trust, you know, the swarm gave me back an adaptive scalar encoder, and that's an encoder that we don't even use anymore. Can I trust that the parameters are good? And I'm like, short answer, no. When it comes to swarming, you can't trust anything swarming gives you. Swarming is like, you know, a best guess after running a model several 100,000 times and testing it a little. I mean, it's like this. It gives you the best it can do, and the best it can do is sometimes awful. So you can't trust any. It'll point you in the right direction sometimes, and you almost always have to take the parameters that swarming gave you, especially the encoding parameters, because that's what it's decent at, is at least finding out what input fields contribute to prediction accuracy, so it can at least get you pointed in the right direction. But for the most part, swarming is a very old tool. We never use it at Numenta. I don't know the last time we used swarming. It's been years. It's hard to use. We don't like it. It's buggy. You know, it's barely maintained. So I mean, my honest advice is don't use swarming. Unless you know exactly what you're doing and you know the exact parameters that you want to permute over. In that case, it can be really useful. But that's like an advanced topic. Like, I couldn't even tell you how to do that. You'd have to go dig through examples in the source code to figure out. There's this permutations.py file that you have to define the different parameters you want to permute over. I've never even done it. So I'm sorry that I'm such a waste of space. That's true, you, Jacob. He just joined and heard me say that. Awesome. Okay, anyway, the last thing, unless anybody else has anything, is the 2D object recognition thing. And I've got a lot I want to say about that. So before we go into that, I will open it up. And I saw Josh just joined. I've got everybody muted. So if anybody wants to talk, unmute yourself, and we'll chat about anything. Otherwise, maybe you're just waiting for me to go into this. Okay. So I'm going to do that then. So first of all, I want to emphasize, I got a whiteboard. So I'm going to draw some stuff, hopefully. So I want to emphasize that we're starting this whole 2D object recognition project. It's really stupid simple. Like, it has to be stupid simple. The more complex you make the environment, the harder it's going to be to solve. So I really want to keep it so simple that that we're focused entirely on the structure of the network. Everything's wired together. And that, for example, so if you have an input space that is just really small, and this is just a grid or a 2D grid or whatever, and we send it an input that takes up this part of it, and that's one object, and then we send an input that takes up this part of it, and that's another object, and then we send one that takes up the middle, and there's 3 objects, and we want to classify That's stupid simple. That's what I want to start with. Something really, or something as simple as here's a box over here, and then here's another one where there's a box over there. That's two objects, I would say, inside some space that we want to classify. Okay, and the reason it needs to be so simple is because the hard part is going to be getting the network put together right. So the first thing is all lessons from the columns paper. Can you guys hear me okay? Because the mic's way over there. Assuming you can.
Yeah,
great. Okay, so the columns paper gives us the idea of an object layer, and this is a pooling layer. And it also gives the idea of a I think they call it a sensory layer. And this is where spatial pooling has happened. And there's mini columns here, and there's cells active within the mini columns. Except instead of like standard temporal memory spatial pooling as we do in HotGem, the distal context is not coming from itself. The distal context is coming from somewhere else, and it's a location context, right? So there's direct proximal sensory input to the sensory layer, and then the location is coming in distal. Okay, and this is proximal. I should probably use colors. I was going to use colors. Anyway, so there's also an input here, and I think this is also a proximal input, and then there's an apical feedback. This is all in the columns paper. And there is sample code that puts this together. I think I linked to it on the forum thread in the 2G object recognition thing. So this one is going to have a sparse representation. So what happens here is over time, okay, so as you're in a 2D space, and say you have an agent here, or a sensor here, and it gets a feature. There's a feature A at this point. So first we have the location, and that's encoded into some SDR, something, and then we have a feature, which is A, and it's encoded into some other SDR, and these are coming like this. So the proximal input, or excuse me, the distal input happens first. If we know the location that we're we're at, or that we're going to sense, that happens first, and that creates predictions here of what we think the sensory input is going to be. Again, this is all just columns paper. Okay, this whole thing, I don't want to explain the columns paper because we have lots of videos about this. So does anyone have any questions about this? Because I could talk about the proximal input here, the pooling here. The important thing is this lateral connectivity, right? And I haven't really talked about this because this is the part we really want to test. I think this is the cool thing that we can do, because in our world, we're not just sending one sensor. We're going to have a little collection of sensors, and they're going to work together to classify objects. They're going to inform each other. That's one of the crucial points of the columns paper. So this would be one sensor. This whole thing would be the cortical column associated with one sensor. And we have another sensor over here, and it's got its associated structure, its cortical column. And these object layers are going to be communicating laterally to share representations. So not only is this going to activate its cells here based on its own sensory space, calculations, it's going to be informed by all the other sensors around it. And they're going to and project its reality. So this is internal reality. Okay, I love using these terms, I know. This is internal reality. Nobody sees this except this cortical column. This is what the column projects. This is its representation of the object for the most part. It's not even really labeled at this point, I don't think. It's just a representation. But what we can do is we can say at a higher level, we can look at all of these columns and see the different representations that each one of them has, and we can run a classifier on them. So we can tell which ones are thinking what object is, and we can have a probability, okay? Does everybody follow me?
Yep.
Okay. All right. So the hard part comes in when you get to the columns plus paper. So we're still going to have, so now I'm going to talk about columns plus. This is a much more complicated paper. I haven't done a video on this. There's a reason. I've got like all these drawings, honestly. So many drawings about columns plus. But you really got to read the paper and figure this out, because so not only do we have the object layer, okay, so we're going to keep this from the columns paper, and we have the sensory layer. So we'll call this object, call this sensory. So we still have this interplay that's going on here, and we still have a location coming in, but it's not coming in from, now we're defining where it's coming from, right? So now we always draw this as a collection of grid cell modules. So this location, and this is, I think, most of the confusion, and especially with Marty, who I hope you're watching at some point, Marty. This is basically the grid cell mechanism, the grid cell module mechanism occurring. It's really tempting to think of it as an encoder, right? Because that's the way it looks like in like the grid cell HTM school episode. And I even showed, you know, an encoding window that says you could easily, you could totally make an encoder that way, and Marty's done that. But this is not an encoder. This is a layer of cells, and the big difference here is an encoder is just one way. Basically, it takes input and it transforms it into something else. This is getting feedback. It's projecting location here, and it's getting this feedback back here so that it can predict what it's going to feel the next time it goes somewhere, because that's very different than just being an encoder. This has to be a layer of cells, like a simulated layer of cells. I think that's the big confusion here. You can't just encode it. We have to simulate this layer. This is going to be a layer in the network that is running grid cell module logic over the 2D space. And we've got to figure out how to make that work. So a quick overview. There is no orientation in this experiment space. There is no displacement in this experiment space, which is different than what I started with. So I confusingly gave a description that included displacement cells. Sorry about that, I was confused. I think we would need displacement cells if we talk about agency of movement. If this model were to start contributing to the movement that's being generated and fed back in, I think you need displacements then, because movement means something different. You know, it's not just an input to the system anymore. It's an input to the system that has effect and a direct effect on where you are and where you're going. You know, it means more than just an input. It's like core to your definition of space. You know what I mean? Okay. I wanted to make sure I didn't miss anything, and then I'll take like questions and stuff. But the big thing is all this is in the columns paper and the columns plus paper, and there's a good amount of code. There's a lot of charts in those papers. To get those numbers in the charts, we had to run these simulations. So there's sort of the small implementations of these networks I'm describing, not the whole thing, but one of this one and one of this one in two different places in supporting material for these papers. What I want to try and do is put them together. And that's really the crutch of the project. And we should be able to test it. Like we could write tests. We could define an input space, and I could fill in part of it and say, this is an object, this is an object, this is an object. And then train a system that maybe just has random movements or maybe has scripted movements. I don't think it matters, because we're not really doing temporal things here. This is really sort of spatial. It's really sort of spatial. Okay. Are there any questions?
Yeah, one thing I wanted to add on the reason that you need the feedback also to the grid cell modules, and that you can't consider it an encoder, is because the representations of space in the grid cell modules are specific to the object. And that's actually important in the Collins Plus paper, because you could be predicting 2-3 objects, and you want to have their representations of the space all at the same time until you've narrowed down what specific object you're sensing.
That's a great point. And as this thing moves, like if we have a sensor moving through the space, you might have a hit here, and a location will light up and the sensor feature will light up, and you'll have a really dense representation up in this object layer, because what it sees is, okay, everything I felt in that location in any object before is going to light up here. So if you've had 6 objects that feel similar in that place, they'll all light up. And as you go to another place and do the same thing, oops. Gosh, I must mute you.
Oh, yeah. So
as you go to other place and do the same thing, then these will narrow down, and as you keep moving, they narrow down to one thing. That's what the columns plus paper does. One of the experiments. Sorry, Josh, go ahead if you.
Oh, sorry. Yeah, I was wondering, is the grid cell representing the objects with respect to the objects with respect to us, or us with respect to the environment?
It's locations in object space.
Yeah, allocentric with respect to the objects themselves. That's one of the key features of it.
So objects with respect to objects.
Right. And if you think about it, well, every this space and every column is, and the representations in this space are going to be unique, right? Because the sensors all have different experiences with features in space over time. So this really can't be shared between objects, and we don't. And I think that's, or excuse me, between cortical columns. This is what's shared, right? There's some computation down here in the guts of the system. There's a representation of space that's not shared because it's impossible to share. I think if they're all initialized, locally right there, and I don't think there's any reason why they would share. But this is important to share. And this bugged me at first a lot because I thought, God, why do these all have to be unique? Why does every cortical column have to have a unique representation of space? It feels like it would be more efficient if they all used the same representation of space, and then they could do direct comparisons, at this level. But I think that it may be a good thing that they all have unique representations. And I don't have a total sense for it. But.
Seems kind of like SIFT or ORB or a lot of the visual recognition systems, but what they do is they compare orientations instead of relative location. So,
are those high dimensional or just two-dimensional? I'm not familiar with SIFT.
I think they're usually two-dimensional, but you should be able to use them in any dimension if you set up the algorithm right. But I feel like this one would have a lot more sparsity if you wanted.
One of the tricky things. Hi, Marty. I'm glad you made it. I'm going to mute you for a minute, though. One of the tricky things with orientation, I think, is a big deal. Like we seem to have a whole collection of cells to represent orientation in the entorhinal cortex called head direction cells. And it makes sense that there's probably something similar in the cortex that have to do with orientation. And it's a hard problem, but the research team has been thinking about this for a long time. Jeff has several ideas that he goes back and forth between. But if we were to do something like this in this space, I like to set up this agent as like north, south, east, west sensors. Southwest. If we were to do orientation here, it would be like giving this agent an orientation, right? And then it could turn and then turn like that and turn like that. Adding that is almost as complicated as adding a third dimension in some ways, to this problem. From the HTM standpoint, this is a hard problem in HTM, the orientation problem that we're still working on.
I think in a lot of cases it could be considered a third dimension.
Yeah, I think so. I think so. And if you think about it from the standpoint of your senses, every one of your senses, when you go towards something, has a different orientation, right, towards that object. And that's all being calculated somehow in relation to whatever object you're interacting with. Every point of contact, you're modeling some type of orientation there somehow, very efficiently.
Yeah, and it's necessary because I look at the coffee cup and it's straight up and down. The edges and whatnot that I'm detecting in the sensors in my eyes are completely different than if it's tilted to the right. So the knowing what orientation your sensor is in relation to the object is just as important as knowing what location you're at in relation to the object.
Well, I'm not quite sure. Deep learning has a lot of stuff where they just use max pooling and the local recognition of the convolutional features, and they can recognize most things as long as they're not completely tilted 180 degrees. But then you take some optical illusion examples where you tilt the face upside down and then tilt each of the features upside down, and then you don't recognize that as strange until you turn the entire face upside down again.
Well,
yeah, I was thinking more. Yes, image is. I probably shouldn't have brought that up as the example, but so imagine you're moving your finger through space. That's probably an easier example to visualize because something similar happens, I'm sure, in the retina. But so you're moving your finger through space. If my hand is turned to the right and I move my close the joints on my finger, I'm going toward the object at a different orientation than if I turn my hand the other direction and I close my finger and I'm coming at it from a different direction. And I can predict what I'm going to feel on that object before I touch it. So I have to be knowing what direction I'm coming toward the object from in order to be able to make that prediction.
Yeah, exactly. And it's not just object orientation. That's really not what I'm referring to at the core of the orientation problem. It's not about that. It's about sensor orientation. And maybe it's the same problem, just looked at from a different perspective. But that, I think the brain solves this from a sensor orientation standpoint, not an object orientation standpoint.
Yeah, it's similar to location problem. You got egocentric and allocentric. It's the same for the orientation, right? Somehow I've got to transform the orientation of my sensors in my entire body into an orientation of the sensor in object space. Just like I need to translate a location in relation to my body to a location in object-centric space.
Yeah, that's right. At the core of this, I mean, this isn't something Jeff talks about all the time, but it seems pretty obvious to me that there's a big link between the computations that are happening in these two places, right? The allocentric space, the egocentric space, as far as sensor in relation to object or agent in relation to environment. It's the same problem, right? Being solved in both of those situations. And they're probably being solved in very similar ways.
Yep.
All right, that's all I got, people. Anybody else have topics they want to bring up?
I've been trying to get started with PyTorch a bit more. I guess I've just been having a little trouble with the pip install and creating PyPy packages. Like I can get PyTorch installed, but not sure how easy it is to release things with it.
I don't know. I don't have any experience with releasing anything. I've run a bunch of PyTorch experiments, but I've never done PyPy packaging with it.
All right. Well, maybe it's just what I'm doing. Yeah.
What kind of releasing are you talking about? Because I have done PyTorch projects in the past, and it's not really difficult. The only problem you might met is that you might want to run your code on a GPU, and the CPU code path and the GPU code path might vary a little bit.
It's more I was trying to have an automatic wheel tester in Travis for continuous integration, and the Linux operating systems there, I believe, might have had some trouble installing PyTorch.
Oh,
so that could be just a specific library issue anyway.
Okay.
That's interesting. I kind of had another idea for my own testing. I wanted to get into autoencoders, since they're able to take visual input and automatically classify them into different categories. Like you can run an autoencoder on the MNIST dataset with 10 neurons in the middle, and they just run convolution after convolution after max pooling after max pooling until they get to those line of 10 neurons without any two-dimensional structure. And then they try to reconstruct the input based on that. And you get closer and closer to the input, and those 10 neurons in the middle start to represent the numbers themselves. So I was thinking of adding some HTM principles to autoencoder, and like a really simple version of that, and see what I could get. Like instead of having the whole filter after filter until the one dimension, I would just do one filter, try to say denoise an image. I guess this would be similar to a GAN, and then see if I could improve it with HTM principles.
Within the filter itself?
Within the what itself?
Within the filters or after?
Right.
Yeah, okay.
Yeah, within the filters. So I was thinking of just doing a very simple thing first, like input image, one convolutional filter, and then another, whatever they use for the anti-convolution, and then the output image that's a little denoised from the denoised input image. I believe that would be a GAN in that case.
So that sounds interesting because, you know, Suraj Raval, the AI YouTube guy, the machine learning guy who does a bunch of videos. Anyway, he did one on Numenta once, and he concluded that HTM was pretty much an autoencoder. I don't think he got the whole concept, but that always intrigued me. So maybe you're onto something.
Well, I think the autoencoder is kind of anathema to HTM because autoencoder is about making dense representations, dimensional reduction, and HTM is all about high dimensionality.
Yeah.
Well, but if any neuron can connect to any another neuron in an input, then I think that would be dimensional reduction. If you have no locality, I feel like that just becomes a one-dimensional problem.
I'll have to look into autoencoders. I didn't really give it a good study, honestly. It's hard enough to understand.
I think I can confirm your point of being a one-dimensional problem if every neuron in the output can be connecting to the inputs, as that's what I experience when I write my library.
Well, you guys can go continue discussing the technical aspects of this on HTM forum. Start a thread about it. I think it's an interesting idea to explore, especially if you have any resources about autoencoders we might want to look into, because I obviously am not educated enough.
All right, I'll do that.
Okay, so I'm wrapping it up unless there's any other ending comments from anybody. Thanks everybody for joining. It was nice seeing you all, and I'll see you on the forum.
See ya.
All right. Thanks everybody.
Thanks, man.